questions, then it's better time to ask questions than when I'm just in the middle of talking. That works with the stream better. So when I've got the question running and I set the timer, you can ask questions. That's the best time to ask questions. You can ask questions at other points, and I'll just tell people that you're asking questions. So, right, going live. Right, welcome to today's stream, and we're looking at a revision course in mechanics and looking at the basics of how to resolve forces and solve all those types of problems. So the knowledge you need to know before you start this, you need to know all your SUVAT equations. You need to know that the resultant force equals the mass times the acceleration. Know that constant velocity means you have equilibrium and therefore there is no acceleration. And know that you can split up a force into components to make it easier to solve the question. Generally, these forces are at right angles to each other. So let's just start off with some nice easy questions. Sorry, that's gone to the wrong point. So what we're going to do is we're going to just find the resultant of these forces. So I'll just do the first one so you realize what I'm talking about. So the resultant force here will equal 5 minus 3 because the 5 newtons goes to the left and the 3 newtons goes to the right. So it's going to be 2 newtons to the left. Okay, give the direction as well. So have a go at doing the next two questions. I'll give you 30 seconds to have a go at doing those. Yep. We'll copy it. It's in all their notebooks. You haven't got a copy. You have to do it off the screen for today. I'll make sure I'll send you a copy and then you can just share it with the rest of your classmates. Right, so that's the first 30 seconds up, and we're going to do this one. We're going to have the resultant force. I want you to keep thinking resultant force when you're doing these problems. And I'm going to resolve to the right, okay, on this one, and I've got 12 minus 7 newtons, which gives me 5 newtons to the right in this question. Okay, and if I'm going to resolve vertically on this one, so the resultant force, I'm going to just use RF from now on to refer to the resultant force, is going to equal 12, sorry, my keyboard got in the way, 12 plus 3 minus 18, and that gives us 15 minus 18, which is minus 3 newtons. So therefore, it's going to be 3 newtons downwards. Now in a question you might have up or down, or you might have left and right, or you might have X and Y as your references, or even bearings depending on the question. Right, moving on. Okay, so we're going to jump onto question 5 now, leave out question 4. I'm going to write the resultant force as a vector for these two. So remember, a vector is going to be looking like that, XY, or you could have XI plus YJ as your vector. You can choose. So I'm going to give you another 30 seconds to have a go at these. Sorry about that. The timer going. Right, so on this one, if we're doing it in terms of vectors, we have got the resultant force will equal, now we don't need to worry about the direction because we're going to write it as a vector. So we've got 8 in the y direction, so it's 0, 8, plus 13 in the x direction, 13, 0, which gives us 13, 8 newtons. Or if you're used to using IJ format, that will be 13I plus 8 j. Notice the I and j's are underlined, okay, to indicate the vectors 1, 0 and 0, 1. That's what they represent. So 13 lots of 1, 0 and 8 lots of 0, 1. Right, this one, we've got the resultant force will equal minus 5, 0. This one's in the negative direction, plus 0, 7. So that will give me minus 5, 7 newtons. And if I were to do it in ij, it would be minus 5i plus 7j. Okay, another 30 seconds to have a go at these two. Okay, that's the 30 seconds up. So we're going to find the resultant force. And it will equal 4, 7 plus 3 minus 5, and that equals 7, 2 newtons. And if we wanted to put it in ij format, that would be 7i plus 2j newtons. On this one, the resultant force will equal minus 3, 6 plus 5 minus 2, and that gives us 2, 4 newtons. And again, you can put that into ij format, 2i plus 4j. Let's just finish off with these two questions. Let's just zoom out a little bit so you can see both. Another 30 seconds to add these three forces up. Okay, that's your 30 seconds up for this one. Don't worry if you can't quite do them. The main thing is to check you understand what's going on. So we've got minus 3, 0 plus 0, 4 plus 3 minus 8 equals 0, 4 newtons. Or you could just write that as 4j newtons. And then on this one, the resultant force will equal, let's start at 7. So we've got 0 minus 7 plus 2, 0 plus 4, 3. And we get 6, and that's going to be minus 1, 2 newtons. Or we have 6i plus 2j newtons. Okay, moving on. We're going to look at some questions where we're going to find the acceleration. Let me just, sorry, I haven't quite got the sheet ready. So just going to get rid of borders and give us more space for working some of these questions. Right, let's view and zoom in so you can see that better on your screens. Okay, so for each of these, we're going to find the magnitude and the direction of the acceleration. So you need to remember that the resultant force will equal the mass times the acceleration. So hopefully it shouldn't take you too long. I think 30 seconds to do these two questions should be enough. Have a go. Okay, that's the 30 seconds up. So we've got the resultant force is mass times acceleration. So we've got 6 if we actually say which way we're going to resolve, we're going to resolve parallel to our in the right-hand direction here. So we've got our resultant force is equal to the mass times acceleration. So 6 times the acceleration will equal 26 minus 8. So therefore A will equal 18 over 6, which gives us 3 meters per second squared, and to the right. Or you could say parallel to x might be better. On this one, if we again resolve, always say which direction you're resolving. So we're going to resolve in that direction, although I'm going to, if I do that, I end up with a negative acceleration, you can see from the question, but it doesn't matter. This is what happens when you get a negative acceleration. So you get 4a equals 12 minus 20. So therefore A will equal, that's going to be minus 8 over 4, which equals minus 2 meters per second parallel to x. And then and from that, we can see it's going to be in a negative x direction because we've got minus 2 meters per second squared in the parallel to the x-axis. Okay, moving on. Let's just make it a little bit more tricky with these two questions here. So we've got it happening vertically. Do remember, actually, no, just do these with just the forces acting on it. There's no gravity acting on these forces at all. Just do it as it stands. So 30 seconds. Ignore gravity on these questions. Okay, that's 30 seconds. We'll start, once questions get more tricky, we'll start increasing the time limit. So again, our resultant force, if we resolve vertically, we're going to get our resultant force will equal 26 minus 12. So therefore 10A will equal 14. So A will equal 1.4 meters per second squared parallel to the y-axis. And in the second one, we're going to resolve vertically. Get into the habit of saying which direction you resolve in, and we're going to get 8a will equal 8 plus 6 minus 14. So therefore 8a will equal 0. So a will equal 0 meters per second squared, and therefore it's in equilibrium. Right, we're going to move on and jump a few. Let's just have a go at question 9 now and give you just 30 seconds to do question 9. Time up. Sorry about that. Just sorting out that phone call interrupted the stream. So question 9, we're going to resolve the easiest one to this. Actually, we're just going to add up the vectors in this question. Okay, find the resultant. So the resultant force is going to be equal to 6, 4 plus 2 minus 3. So we got 10a will equal 8, 1. So therefore a will equal 0.8, 0.1 meters per second squared. And because we've done this as a vector, we don't need to give a direction because the vector includes the direction. If you want to do it in I and J format, 0.8i plus 0.1j be our vector. And notice I need to underline my A because that is a vector. Okay, so first wordy question here. I'll give you 60 seconds because it's going to take a little reading time, which you can do while I'm talking, and see how you get on with that. How's that for time? Another 30 seconds, or you've done? Anybody finished? You can answer, it's on mute. Nobody's finished. Okay, I'll give you another 30 seconds or another 60 seconds. Just going to give you a little bit more time to finish that. Okay, let's go through this question then. Right, we know that u equals 0 meters per second, and we know that s equals 10 meters, and we know that t equals 3.5 seconds. So we're going to use s equals a ut plus a half a t squared to help us find the acceleration. So we know that 10 equals 3.5 squared over 2a. And so therefore A comes out to be 1.6326 meters per second squared. So if we resolve in this direction here, we got 1.63 times by the mass. So our resultant force will equal all the forces in the same direction. Now we know that it moves in the direction of P. So we're going to do P minus 28. So therefore, I'm just checking this, P minus 28. So therefore, P will equal 1.63 plus 28 times by 10. So that's roughly 16 plus 28. So P will equal 3844 newtons to the nearest newton. Sorry, just that I made a mistake in my original question. I wrote it in the wrong direction. So therefore, I had to think of that on the fly comparing to my original question. Sorry about that. Okay, next question. Let's have a look at question 11. I'm going to try and give you 2 minutes to do this one, so you've got plenty of time to think about it. That's annoying. My model answer was wrong. I spotted it on the fly. I had 28 minus P. You'll get 44. No? You were. No. Is this the right level? It's not been too easy, is it? You'll see the difficulty just keeps going up and up now. Right, that's 2 minutes. How are you doing? Are you finished? Has anybody finished this yet? Yeah, okay, all right. Go through it then. Right, so that's the 2 minutes up. Let's go through this. So we've got our particle here, and we've got Q going that way, and I'm going to do 25 newtons going this way. Given that A moves in the direction of 25 newton force and accelerates from 5 meters per second to 9 meters per second in 8 seconds, find the value of Q. So we can see that as it's constant acceleration, we're going to have it accelerating from, we use this formula, A equals V minus U over T to find our acceleration. So that will equal 9 minus 5 over 8, which equals half meter per second squared. That's our value of acceleration. Now, if we resolve in the same direction as our 25 newtons, okay, we're going to get our resultant force, which is going to be a half times by the mass, so ma times a half, 7.5, will equal everything in the 25 newtons minus everything in the opposite direction. So therefore Q will equal 25 minus 3.5, so Q equals 21.5 newtons. Right, next one we're going to have a look at is question 13. Here we go. So a particle of mass 5 kilograms suspended by a light inextensible stream. The particle is being lowered at constant speed. We will be taking gravity into account in this question. And you can just use gravity as G. Give your answers in terms of G. I'll give you 60 seconds to finish that off now. Okay, that's 60 seconds up. Now, always start off with a good diagram. So we've got the tension is going to be pulling it up on the string, and we've got its weight acting down, which is going to be 5g. It's being lowered at constant speed, so the velocity is equal to 2.3 meters per second. Now, if it's got constant speed, this means A equals 0. So therefore, we have what we call equilibrium. So therefore, our resultant force I'm going to write the word resultant force here to make it easier, will equal T minus 5g, but our resultant force is 0 because there's no acceleration. So we get T minus 5g, so T will equal 5g newtons. Other ways to do resultant forces when you've got resultant forces is 0. If you know you're in equilibrium, then you can do all the forces going one way equal all the forces going in the opposite direction. Is the other way to do that question. Right, finishing off today, this question, something a bit meatier. I'm just going to zoom out slightly so you can get the whole question on screen. Question 16. Sorry, gone off screen. Okay, question 16. I'm going to give you a good 3 minutes to have a go at this question, I think. Looking at it, I'm going to actually make it 5 minutes. I've got a class with me. If they finish it earlier, I'll stop it in less than 5 minutes. There is no diagram drawn. You should be able to draw your own diagram without any problem. Okay, all the information is given to you in the question. Have a go at this. See you in 5 minutes. Read the question. Any of you watching on the average watch time? 26 minutes. Okay. Sorry. Come on. I'll email to this and they can share it with the other set. There's only one because you have 3 sets taught by me and one's not, isn't it? Transmitting a bit rate of 1 minute to go. Mm-hmm. 30 seconds to finish it off. Yeah, 5 minutes. How are you doing? All managed to get to an answer? Or do you need another 30 seconds or a minute? Who's got an answer? Okay. Right, I'll give you an extra minute because the class haven't quite got their answer to C yet. So helpful having you guys here. Pace it back. Well, I think 5 minutes. Not good. Three, two. That should have given you a good chance to have a good go at this question. Let's go through it. So, if we draw the two vectors in, so this is going to be Pi plus Qj, and this one's going to be Pi minus Qj going downwards. So both P and we're going to have frictional force is 180 newtons directed waste. And those are all the forces acting on our box for this question. So therefore, our resultant force will equal PQ plus P minus Q plus minus 180, 0. And that gives us 2P minus 180, 0. Okay? And for part A, essentially is what we worked out here, it must move in a straight line in the east direction because the frictional force will oppose the motion, so therefore it must be going to the east. But this basically, we know that 2p is going to be positive and it's going to be greater than the frictional force because it opposes the motion. Therefore, as 2p is greater than 180, it must be going east. If 2p wasn't bigger than 180, then it wouldn't move because the frictional force would be too great for the forces for it to overcome. So given the acceleration, so we know that a is equal to 0.003 p meters per second squared, we can know that our mass will be equal to 1400 divided by whatever you've taken to g. So I didn't give you g, so if we say 9.8. So if we use 9.8, we're going to have our resultant force will be 142.85 times by 0.003p, and that will be equal to 2p minus 180. When we simplify that, we get 1.57 and the rest p equals 180. Make sure you keep the whole like number on your calculator. So p, when you divide by that, will come out to be about 414.5. Now, to find, we know the tension in each rope is a magnitude of 200 newtons. Find the value of Q. So that's our P component. That's our Q component. So therefore, we've got P and Q. P squared plus Q squared must equal 200. So we know that P squared plus Q squared must equal 200. So this is my part B answer. So therefore I've got 114.5 and all the rest of it squared plus q squared equals 200 squared. Sorry, I didn't write 200 squared there. Solve that, which I'm sure as an A-level mathematician you'll be able to do without too much difficulty, to get 163.9 looking at my answer that I wrote earlier. Right, that will do today. There are other questions which you can have a go at, and I actually have done some other answers as well on some of these questions. You can have a look at those too. I'll be streaming tomorrow, and I'll be going on to the gravity questions tomorrow.